All right, welcome back. So we're going to finish up this afternoon talking about managing the VIA environment. And what we've done with this section is we've pulled together a few topics that are somewhat new to VIA 3.4. So a couple of things that are brand new tasks that an administrator might be asked to do. And we've coupled that with a couple of standard tasks that we really need to cover as part of the core knowledge of an administrator. So with VIA 3.4, Jerry mentioned yesterday, one of the new features is that we can have, within one deployment, multiple CAS servers. Okay. Previously, we could only have one per deployment. So when would this come into play? So yeah, you've got different users, maybe different usage patterns for those users. You have some that are very high-end analytic modelers that need lots of processing power. I might have some others that are simply running reports on smallish data, right? I might have different needs. I might want to separate information by departments. So maybe one department can only afford a non-distributed server. Very small, they don't have much data. I can allow them to have one server and have my higher power users use the distributed environment. Now, there is a licensing aspect to this. So currently, your VIA environment is very dependent upon the number of cores in your CAS server for the licensing. So if you add a new CAS server, for example, that could potentially have an impact on the number of cores that your customer needs to license. So it's not something you can just do willy-nilly. You have to really adhere to the licensing. The new machines that you're going to use for your additional CAS server cannot or should not contain any other VIA software. So I don't want to reuse something that's running mid-tier information, for example, as a CAS server. I want it to be a blank machine. I want it to not have any other CAS processes running on it or VIA processes. And then, of course, if I have, I still have to adhere to all of the prerequisites as far as being able to SSH among machines. This is not a deployment class, so the other track that's going on across campus is getting into a lot of detail about the prerequisites. How do you provision a machine to be ready to deploy software on it? So if that's your thing and you really want to learn more about it, I encourage you to go to the VLE, and you'll get more than you probably bargained for if you go there. Right? So what is the process? If I want to add a CAS server to my environment, assuming I have the machine provisioned and all the prerequisites done, the actual deployment is pretty simple. I have to edit a couple of files. One is a vars.yaml file. And in this particular file, all I really have to do is name my new CAS server. Okay? So generally speaking, we take the original vars YAML file, we copy it, we edit it, and we save it with a name that matches the CAS server name. So in this case, I'm going to create a new CAS server called geladmin. So I create copies of those files for the geladmin vars, and I also need to modify an inventory file, which is simply a list of the machines in my deployment and their purpose. So create copies of those two files. You run Ansible. It takes care of deploying the software, laying down the binaries, configuring everything, and once that command finishes, you're done. Right? That server is up and running and it's available for your users. So in our vars.yaml file, again, all we're really doing there is naming our server. So I'm sure you've seen in Environment Manager and some of the other work that you've done this week, you see CAS shared default is the name of your CAS server. Default is the name. Right? So if we create a new server called geladmin, we're going to see CAS shared geladmin as a new entry in our server list. The inventory file is, again, where we lay down the names of our hosts that comprise the environment and also their role in the deployment. So generally speaking, if I'm going to deploy just a CAS server, I can get rid of almost everything else. There are a few things that I need to leave in there. For example, host definitions, I need to know the name of the machine. And I also, down there on bullet number 3, I need to specify the role in the CAS environment that the machines are going to play. So if I have a distributed environment, I need to name a primary controller and at least a worker. If I have a single machine, I just have a primary controller. Okay. But it's no different than the regular deployment. So it does create a secondary file for inventory, and it creates a secondary file for the vars. Okay. So again, once Ansible finishes, there's really nothing more for me to do. I simply go to Environment Manager, and wherever we saw earlier the CAS shared default server, we'll now see a pull down that lists the additional CAS server. Okay. If you go to the servers page, you'll see it listed. Okay. So plugging it into the system and having it show up in the user interfaces is very straightforward. Really not much for you to do at all. All right. So one word of caution. So we're going to talk later this afternoon about startup and shutdown. And a lot of that work that's kind of stemmed from some of our colleagues in GEL really is dependent upon the inventory file to know which machines need to start and stop. Well, if you have multiple inventory files, that means that the startup and shutdown gets a little more complicated. So if I have my original environment that I can start and stop at will, I now need to create kind of a second orchestration to bring my secondary CAS server up independently. So it introduces a little complexity as far as some later processing. Updates. Updates are dictated by the inventory file, so if I have multiple inventory files, there's the chance that I have to run update multiple times, once per inventory. All right, so here's your chance. You're going to add a new server. So in your deployment, you have CAS01, which is your first controller. You have CAS02, which is a secondary controller. And you have CAS03, which is your worker. You also have a blank machine called CAS04. So what I'd like you to do now is carry on with the exercise 3.1.1. And all I want you to do is to get to the point where you're running the Ansible command. So once you run the Ansible command, if you would put your name tag on the top of your machine so I know who's done, it may take a while. I don't know, it takes anywhere from, the record we have so far is 7 minutes. So if you'd like to go for that, I'd like to know. It can take anywhere from 7 minutes to 2 hours. Right? So again, we're at the mercy of race here, so it depends on what's going on. It's not anything to do with the software. So once you run Ansible, run that command, put your name 10 up, and then we'll go on with the next section while we wait for that to finish, and we'll come back to it. All right. While our Ansible is running and deploying the software, we're going to move ahead with the next section, and then at the end of this hands-on, we'll have a chance to go back and validate that our additional CAS server is there. So, again, touching on a new topic for VIA 3.4 is CAS resource management. So what we're talking about here is the ability to take a single CAS server and determine who gets access to which resources and in which proportions. So if I have a server, for example, that's been split between people paying for the resources, obviously they want to be able to have access to those resources in a proportional way. So when we get to this, we could set up this for things like controlling what priority our developers have versus our users. So I could either set my developers down a level and say, look, they're just working on creating reports. The performance really doesn't matter that much to them, but my executives and my sales managers and those kinds of people really need more important information to run the business. So it's just a matter of determining what groups of users you have and how you would like to dole out the resources for the CAS server. Now, what we're really talking about here is controlling two things. One is the CPU share. So CAS is obviously a potentially big user of the CPU when we're doing lots of high-end analytics. We also are going to control something called CAS disk cache. And Uttam and MK and Steve are going to talk about this in great detail tomorrow and Thursday. So I'm not going to get into a lot of detail. But the CAS disk cache is space on the disk that allows me to throttle the size of the tables that people can store. So we'll come back to that. If there are questions about this later, we'll certainly be around all week to help you. Now, we do depend on Linux C groups for this operation. So C groups must be implemented on the operating system. And this is distributed or non-distributed, so it doesn't matter. Either form of CAS server can have this resource management capability. But by default, it's off. So as part of the tasks of an administrator to implement resource management, we have to turn it on. So what we're going to do is set up resource policies. So a policy currently can only be done by a CAS super user. Obviously, we're dictating what happens to the CAS server. We want that to be done by a responsible party. If I set a policy in place, it applies to all machines on my CAS server. So if I have a 20-node distributed CAS server, all 20 nodes behave the same. I can't change it on a per-node basis. We're going to be using some command line commands to store the policies, and we're also going to persist the policy rules in console, or the SAS configuration server. So that's where the rules are going to live from start to start. So here's our high-level process. So we're going to turn on resource management. We're going to create policies. So we're going to dictate what groups have which proportion of the resources to use. We're going to create groups that correspond to each of my policies. So if I have a policy 1, I'm going to have a policy 1 group, and anyone who's in that group gets policy 1. Right? Pretty simple. And then finally, in order to pick up all this new stuff, we have to restart CAS, unfortunately. So I don't see policies changing all that much. I mean, it's not something you would probably change 10 times a day. So I don't see that being a big problem. But it would be something that you need to consider in terms of having to restart the server for the new policies to be picked up. So let's go through each step. So turning on the CAS resource management. All we have to do here is go to the CAS config Lua file, CAS config user mods. Obviously, we want to make changes to the file that's going to persist our customizations. And we simply set an environment variable. So CAS enable console resource management to true. Okay? So that's all that's needed to turn it on. We have to restart the server to pick that up. The next thing we have to do is make the policies. So these are the definitions of the policy usage that I want to implement. And there are 3 types of files. One is a policy level, or a priority level. And I can have up to 5 of these that determine the CPU and the disk cache for a group of users. I can also set once for a CAS server a global CASLib definition limit. So in this one file per CAS server, I can determine how big the CAS global libraries can be. And then I have an override file, which is the priority assignment. So if I have special users like, say, Dr. Goodnight, or someone that I want to have, I don't care what's happening, I want them to have priority 1, I can have a file that has per user an override so that I can dictate for individuals what their priority is. Okay? So we'll step through this. SASAdmin is a great tool because it now, with the new version of VIA, will generate some sample files for me. So a lot of the tasks that we need to feed JSON files in for, things like task definitions, policy files in this case, we can run SASAdmin and have it generate these templates. And all I have to do is then copy the files to where I need them, edit the template, and I'm all set. So it's a big head start on getting all the files set up. So by default, we get one policy or one priority level. So by default, we get priority 2. So what we're going to do is take that priority file and copy it for 1, 2, 3, 4, and 5. All right, as many as you need. Okay. So we're going to duplicate that template, and the structure is very simple, as you'll see. So we're going to have up to 5. You don't have to have 5, but you max out at 5 levels. And in that file, what you see is a CPU share at the top. So in this case, I have 55 shares being allocated to this priority. I have the disk cache space that I want to allocate to my global CAS user, and so on. So the HDFS storage I can dictate separately, and then finally I can control how much session space their tables can take up. Okay. So for this priority level, I've defined a CPU share and as well some disk cache space limits. Those numbers look large, they're in bytes. Currently there's no way to shortcut that, so you can't say 3G like you can in some of the other SAS configuration files, so it's bytes. I think one of the slides has a link to a converter, so if you need exact byte limits or gig limits or megabyte limits, you can convert those. Right. Now down at the bottom we have the policy name, and that's going to be very important because later I am going to need a custom group that matches that name exactly. And that's how I associate a user with this policy. Now, similarly, one of the other template files I have is the global CAS libs. So in this case, you see a few of the global CAS libs that come defined automatically. You can add others in. Okay? So if in the exercises, when you define space for your global CAS libs, if you don't see it referenced, just add a row. Okay? Now you can say all here, underscore all underscore. So that would say I only want, or I want all of my global CAS libs to be limited by this number. Okay? So there are some shortcuts if you don't want to list them all out individually. But there's only one of these per CAS server. And then finally, my priority assignments. As I said, this is how I override those policy files to say, I want these users to be forced into these priority groups. All right. So I define the files. I edit them. They're just JSON files. Text editor will do. I now need to load those files into Consul so that the CAS server knows to pick them up. And to do that, I have to use a SASAdmin command. So in the top example, you see there the priority level 1 file being loaded. And I would repeat that for each of my policy files. So if I have policy or priority level 2, 3, 4, and 5, I'd have to repeat that command. Right. And likewise, we simply load the global CAS lib policy and the priority assignment policy. So now they're in Consul. CAS knows to pick them up, or to look for them at least. Okay. So the last thing I have to do is create custom groups. So in this case, you go to Environment Manager, the Users page, and you simply have to create a custom group that matches the name of your policy file and move whoever you want in there. Okay. So pretty simple. Okay. Now, what happens? This is kind of a daunting diagram, I suppose. When CAS starts up, it reads the policy files and it creates on the fly dynamic C groups for each of your policies. So if you have 3 priority levels defined, it will create C groups for each one of those policies. It will then associate the users to those policies based on their custom group membership. And then when CAS runs their process owned by that user, it knows how many shares to allocate to that particular group. Okay? So it's all handled for you behind the scenes. You don't really have to worry about it. When CAS shuts down, it deletes the C groups. So they're kind of transient in terms of the Linux world. If you were to go out, you can see them as long as the CAS server's up. Once the server dies, those C groups go away.
Sure. So one of the examples is we have, like, the salespeople get 75 and HR gets 25.
Mm-hmm.
And we've set up these policies and we've given them their limit. Is that just 25 of the total period and they can never go above it? Or is it 25 of, like, because sales might not be using any at that point in time?
Yeah, really good question. So Jane was asking if I limit someone to 25% of the resources, is that all they can use? And mainly the CPU, I guess we're talking about here. And the answer to that is no. If the system is not busy, you get as much as we have. The only time these come into play is when the system is at capacity, and I have to now decide who gets higher priority of their jobs. So if the system's not busy, you won't even know these are in place. Okay? Other than the CAS lib limits, but the CPU by itself. And normally what we do, I didn't mention it earlier, but with the CPU shares, the recommendation is to dole those out as part of a 100 total. And that way you're dealing somewhat in percentages. So if I say someone gets 55 shares of the CPU, I now have 45 that I can distribute to the other groups. Right? It's not a requirement, but if you set it over 100, now you have contention again. All right, good question. All right, so we have some potential conflicts, right? What if I have a user who's in multiple groups? In this case, Ahmed is a member of both custom groups priority 1 and priority 3. So priority 1 is the highest, priority 5 is the lowest. If you belong to multiple groups, you get your lowest priority. Okay? By default. Okay. What happens if you're not in a custom group? So Ahmed submits work, the system's at capacity. I don't know how to position Ahmed's job in the rank of things to do. So if I'm not in a custom group, by default I get the lowest priority queue. So what this means is that generally speaking, if you want to define policies, you should, as a best practice, include all users, right? Create a group for everybody else, unless you want them to end up in the low end. Oh, no, yeah. So the question is, if I'm at the lower priority, will I never run? Potentially. You'll always get some share, but it will just take longer to run. So it will swap your job in and out if someone with a higher share gets active. All right. The last one we're going to look at is a case where I might be in a custom group, I might not be in a custom group. But if I'm in the priority assignments file, it doesn't matter. So in this case, Ahmed is a priority 1 in my priority assignments file. So I don't care which group he's in, he can be in all of them for all I care. No matter what he does, he's going to be assigned priority 1. Right? So that's how that override works, is you don't have to be concerned with groups. So again, if you have special cases, you can ramp those people up or down as you see fit. All right, so a couple things to think about. So as I said, one of the things is if you define policies for one, you should consider assigning policies for everyone, or at least defining policies that include people in the correct group, knowing that if you don't put them in a group, they get the lowest priority. So you just have to factor that in. when you're defining the groups, you need to kind of have some idea of who the users are. So for example, if I put all my high-end analytic users in the lowest priority, they're going to be waiting a long time potentially, right? If the system gets real busy, they have the lowest priority. So you just have to determine how many users fall into a category and kind of what their workload is. And as Jane led me to earlier, this really doesn't matter if the system's not busy. If there are adequate resources, everybody gets as much as you can possibly get. But if the system gets busy and it reaches capacity, now I have to decide who gets what. And that's when the policies come into play. So what we're going to do now is one more hands-on. Hopefully, has anybody's finished the CAS server? Dean, Sid, Chase, everybody? Okay, cool. So all we want you to do now is, for the first part of this hands-on, just go verify that your additional CAS servers showed up. All you have to do is open Environment Manager and drill around there for a little bit. But once you do that, we're then going to define resources for the CAS shared default server, the original distributed server. Again, this is going to take a restart, so there'll be some time that you have down. So once you get things all modified, I believe the instructions have you do all the changes and then start once at the end. All right, so we're going to finish up this afternoon talking about two topics. One is CAS server startup. This deals with configuration and kind of an auto exec for my CAS server. And then we're going to talk about orchestrating the startup and shutdown of my environment. So one of the things I have to do with my CAS server specifically is sometimes tailor it to the needs of my customers. So certain environment variables need to be set to dictate where it puts certain things like the disk cache, how much memory it uses, how many cores, that kind of thing. So it's a very customer-specific thing that happens. Normally in the CAS server, we have a hierarchy of files that we will configure for this process. So in this case, we have, in number one, we have a CAS config Lua. So this deals with setting environment variables for the CAS server, right, as it's coming up. There's a user mods file that I want to make changes to. You don't want to touch CAS config Lua because it could potentially be regenerated by Ansible or if I update or redeploy the software. So only make your changes in the user mods file. We have a node-specific user mods in case I need to tailor a single node for some reason. To be honest, I have not seen a reason for that in our experience. So it's there for a reason. There must be some, but I haven't discovered it yet. And then there's something called a CAS startup, and this is more of the auto exec for CAS. What do I want to have happen as the server starts up and before my users get in? So we'll take a look at some of these. So CAS config Lua, obviously writing Lua code. You must write Lua code in this. Do not edit unless it says user mods, because your changes could potentially be overwritten and lost. So we want to make changes to the user mods file for this. And again, these are things that are just environment variables. Usually it's a very simple name equals value pair that we're going to edit. As an example, we may have the need to restrict the number of cores that CAS uses. Now by default on a machine, if I license 8 CAS cores, CAS will only use 8. You can have 1,000 cores for all we care. We only use the licensed version. But there are cases where I want to start a CAS server and I might know that I have 20 cores licensed and I want to specifically divide those up between 3 different machines. So that's a case where I would want to use this particular option, max cores, to say on the first machine only use 2 cores. Right? Otherwise, CAS is going to use up to the license. Okay? So it's just a very simple name equals value pair there. The startup file, similar, auto exec. These are actions that I want to have take place before the users get on the system. So this could be things like loading up big tables for my users, It could be creating formats, loading the format libraries, as Jerry talked about this morning. And so anything I want to have happen before the users get access to the information. Okay. So when this happens, when you start CAS, it goes through the configuration, it starts up, and initially it creates what's called session 0. It's the first session that CAS ever runs. And it's going to go through the processing here. So it's going to run the normal startup. It's going to run your user mod startup. And then it runs something called startd, which are startup commands that are issued by R&D for some of the solutions. So generally, you do not want to edit anything in the startd. It's just a directory of files that the solutions are going to make use of. Okay. All right. So Uttam is going to talk tomorrow about a lot of data options. One of the reasons for this file is if I need to load data that takes advantage of some of the options that I can code but not do through the user interface. So for example, if I need to partition data, or if I need to compress the tables when they go into memory, right? Those things have to be done through code, but I want them to be done automatically for me every time the server starts up. So these are just one-time only auto-exec type actions that you want to have take place. So as an example, we might want to stick a load table action in this file. So possibly the sales history file is huge. I don't want the first user to pay the penalty for having to load that table to memory before their report comes up. So I preload it. This comes into play quite often if you have data that's in Teradata or Oracle, where we need, maybe it takes a little bit of time to pull that data over. So just something to keep in your toolkit. Yes, sir.
Can users run sessions before session 0 has finished executing?
So can users run sessions before session 0? No.
Can another user start using other parts of CAS before it's finished loading?
Sure.
Okay.
Sure. Yeah. Yeah. So the question is, do I have to wait for the load to finish before I can get access to everything? No. It's a serial thing. All right. Good deal. So with your permission, what I'd like to do is finish the next section, and then we'll just turn you loose for the rest of the day on the hands-on. So there is a hands-on if you'd like to walk through how to do a startup of CAS, and it involves restarting the CAS server, of course, to pick up the changes. So we're going to defer this and just finish up talking about startup and shutdown. Okay. So the good news is that when I have VIA, there is a service installed on each and every one of my machines called SAS VIA All Services. And it is kind of like the SAS servers script that we had in SAS 9. It's responsible for starting all of the services on that machine. Not across all machines, but just on that machine. Okay. So it has to be run as root or with sudo privileges, but it takes care of handling all the dependencies, takes care of starting things in the right order, takes care of bringing up everything that VIA needs on that one machine. Okay. Now, one of the little intricacies that you have to be a little aware of as an administrator is there are two types of services. Some are called System V, and some are, what's the other one? System D, right? And if you use the SAS VIA All Services, it takes care of starting things and stopping things using the right protocol. Okay. The thing that comes into play here is if you start something with a system control command, you want to make sure you stop it with a system control command so that all of the artifacts get cleaned up afterwards. Lock files, process ID files, that sort of thing. So System Alls or SAS VIA All Services takes care of that for me, but just we wanted to mention it so that you know if you manage services individually, you'd have to keep that in mind. Okay. So for a non-distributed VIA, so we have, for example, the EEC machines. You can get one out of RACE. It gives you one big, massive machine that has all things VIA on it, It's one virtual machine. In that case, when you run SAS via all services, things start just beautifully. Because everything's on that one machine, it knows which services depend on which other services, and everything starts up and is orchestrated just perfectly. Right? So that's the best case, a happy path. What happens if you have a distributed system? Remember, each machine has one of those SAS via all services. So unless I can control which order those machines come up in and know which order they should come up in, I run the risk of having kind of an arbitrary startup order. So in this case, the machines start up. Some services that depend on others may come up too soon. Right? And we're just not at the point yet where all the services coordinate each other quite well enough. So with the distributed environment, it's kind of incumbent upon me, the administrator, to orchestrate the startup. So what do I need to do? The first thing I need to do when I have a distributed environment is I need to know what order the services should come up in. So the first thing we want to bring up is console. It's kind of the configuration manager, remember? So it has all of the registrations for which ports should be used, which machines have which services. It's kind of the orchestrator of information between my machines. So we want that up first, the server, and then I start the agents for console on each and every machine in my deployment. That's the first thing. Second thing. Third thing is my secret manager. This is my favorite part of VIA. This is where SAS persists things like certificate information, passphrases, all of the information I need to handshake between my machines. Right, so obviously that needs to be up so that they can communicate together. The message broker, we've seen the importance of that. It's where I put messages so that everybody knows where to go to get information. I can start my data server, which is Postgres behind the scenes. In order for CAS to work, I need my proxy server to be up and running. And then finally, I can start everything else. So there's 7 things you need to be concerned with coming up in that order. Okay. So the big rule is never start CAS without console being up, because it just will not come up. Just a kind of a special note about the CAS environment. In our particular workshop environment, we have 3 pieces of CAS. We have a primary controller, we have a secondary controller, and we have a worker. Right? I don't really have to start all 3 of those myself. All I have to do is start the controller, and it takes care of starting all the other CAS components. So really the only piece you have to start is your primary controller, and it will take care of the rest of the CAS pieces for yourself. Right? Now, when you start up, a lot of these processes drop artifacts. So they can be process ID files, they can be lock files, they can be registrations in console. So one of the things that can happen, and does happen quite often, is if your system shuts down inappropriately or ungracefully, these artifacts can be left around behind. So when I go to restart, things get really messed up because it says, oh, you already have a process ID, you must be running. I'm not going to try to start you again. Okay. So for a distributed environment, it's very important that we shut down gracefully whenever possible. So it's just the opposite, as you might imagine. So if I have one machine, I can run SAS via all services and things shut down appropriately. And it's exact opposite. So in this case, if I have a distributed environment, I would stop all of my ancillary services like CAS, all right, and then work my way back up the list. So the proxy, the data server, the broker, the secret manager, and finally console. And again, the big rule here is please, please do not stop console before everything else. And the reason, again, is that console maintains registrations of where your services are located. So if it shuts down and it still thinks your service is up and running, and it still thinks it's on port 8740, it's going to try to connect to that next time, and it's not going to work. I think we talked about all this before. The only other thing is Postgres can occasionally, if you have a highly available Postgres environment, you can get some conflicts there with the conf file, or CDF file rather. So again, I think there are lots of notes and lots of tracks about how to clean up from that situation. So how do we do this? We use Ansible. And I know you're not in here for a deployment class, but the other track is going through a great deal of information about Ansible. It's an orchestration software that allows me to, from one point of contact, issue commands to all of the machines in my deployment. So now I can run one command and have it start things on any number of machines and any number of order and shut down similarly. So our colleagues in GEL have created a playbook that we have made available externally in GitHub. So customers can download it. It's built to interrogate the inventory file and start up any number of deployments in any proper order. So I encourage you, if you have customers that call up and want to know how I start the system, we can point them to that location. And I believe that page in your notes has a link to the location. All right, so for this, there's really no hands-on for the startup and shutdown. It's very resource intensive, and as you can imagine in the race environment, that's a little iffy sometimes. So we have a blog there that our colleague Gilles wrote. It also explains how the Ansible playbook is formulated, how it works in terms of interrogating the inventory file and so on. So if you're interested in the inner workings of that, it's certainly available for you.